7. So this is the double angle identity section. So it comes from these a little bit. You're going to see why. But anyway, so consider the statement sine 2a equals 2 sine a. So is sine 2a the same thing as 2 sine a? So kind of spoiler alert, they're going to give you this setup like we had last lesson where they're going to make it look like, oh, it could be that easy. No, it can't. So sine of 2a, a is pi over 6, equals 2 sine pi over 6. And so you're just going to figure out those values. Well, what's 2 pi over 6 for the left side? Pi over 3, right? Pi over 3, so the left side is root 3 over 2. The right side is 2 times what's pi over 6? Pi over 6 is 1 over 2, right? So 2 times 1 over 2? 1. Root 3 over 2 does not equal 1. So no. They're not the same, correct. Yeah. So if you don't like this part, you can just ignore it, I guess, but there's no, it doesn't work that way. Right. So not equivalent. Okay. This idea is actually a little bit easier. So let's just ask this in general. What is a way that you could write 2a with addition? So how could you write, because 2a is a multiple, right? 2 times 8. How could you write 2a with addition? It's very basic. No, not that general. I'm just saying, just think 2a. How could you write 2a in terms of addition? A plus a. Yeah. A plus a. Yeah, a plus a. So explain how the sum identity of a plus b could be used to help us. We could do sine a plus a, and that's why I said we can kind of use these double angles come from the idea of the sum difference, but it's a sum of the same thing. So instead of ab, we'll have a's, all a's. Okay? So prove that sine of 2a equals 2 sine a cos a. So here we go. We're using the stuff at the top, those formulas at the top. So sine of 2a, we're going to treat that as sine of a plus a, and we're going to do the sine formula. So it's going to be sine a cos a plus cos a sine a. Well, is sine a cos a the same thing as cos a sine a? It is. So we have 2 of them. And so we proved it. So there's your first double angle idea. Okay. Now we're going to take that same idea for cosine 2a. We're going to write cosine a plus a. And we know that cosine goes cos a minus sine a sine a. So you can clearly see cos a is cos squared a. Whoops. Minus sine squared a. So that's your double angle for cosine. And now we're going to do the one for tangent a plus a. Okay, so tangent a plus a would be tan a plus tan a on top, 1 minus tan a tan a. And so you can see it simplifies too. Tan a plus tan a is 2 tan a. These identities are a lot easier than the ones we just did. And then 1 minus tan squared a, and I'll get out of the way. And so we've simply got them. Now we're going to go ahead and use them for the next 3 examples. Any questions? I'll pause for a second. Yep. All right, so let's get to the examples. All right, so a couple things though. So we talked about the top layer here. All is fine. These two, the bottom layers, just so you know, they're just conversions because cos squared and sine squared kind of come from the Pythagorean identity. So remember, we can write sine squared as what? How could you write sine squared? Well, we know that sine squared x plus cosine squared x is 1, right? So they're right here. See it? So what they did was they replaced sine squared here with, it was a minus sine squared. So they did, they actually did this. Like that. So see, cosine squared A equals 1 minus sine squared. We'll just use that for a second. So see this right here? We just did this. Cos squared equals 1 minus sine squared A. So that cos squared right there, we can replace with 1 minus sine. So then we'd have 1 minus 2 sine squared A. That's where this guy comes from. You're replacing them with the Pythagorean identity for a different form. So we took this cosine, we replaced it with 1 minus sine squared. Okay? Then they took this sine squared, they replaced it with cosine. That's what got this one. I'm just telling you these two that you didn't see came from replacing them with the identity. So for example, if you wanted cos 2a in only terms of cos, then you could go ahead and replace the sine with the Pythagorean identity to get just the cos in there. Same thing if you want it to be just in terms of sine, you could do that as well. All right, let's look at this one. All right, so prove 2 tan x over 1 plus tan squared x equals sine 2x is valid and state the non-permissible values. Sweet. So this is just like we started class. Left side equals right side. Hang in there, weirdos. Okay, so what is 1 plus tan squared x? That is, when you see anything 1 plus and you see squares, you immediately should look at your Pythagorean identities. Okay, good. It's secant. So secant squared. I'm going to write the top is 2 sine x cos x over secant x. Yes, we'll write secant as 1 over cos. Okay? And so then we're going to write, like what Hannah just said, we're going to write 2 sine x cos x over 1 over cos x. And that's a square, because it's secant squared. Okay? Now, okay, you get this fraction stuff. The 1 goes here, the cos goes here. 2 sine x cos squared x over cos x. So you get a cancel. So you get 2 sine x cos x. I'm going to stop there for the left side. Oh, wait a second. Okay, any questions with how I got there? That's a question, Tori. It's fine.
I don't even know how to ask questions. Well, like, I don't even know how you went from that to that. Like,
Okay, so we'll explain it again. That's fine. So tangent is sine over cosine. This right here is an identity in your book that you need to look at. That identity equals secant squared x. So those are just substitutions. There's really no math involved. Now the math involved is now here, I took secant, because secant we know is 1 over cos. So I wrote 1 over cos, but it's squared, because it's a secant squared. That goes middle, that goes top. That's the math part, probably. Okay. Why do they do that? Yep, because it'd be sine x cos x. What's this bar mean? Means divide, so we're going to flip and multiply. So you flip and multiply them. So that's why, in terms of when you don't have them lined up, that's why I say underachiever, overachiever. You can just keep it the way it is. But, yep. And then here, once we're here, you get 1 cos to cancel. We have 2 sine x cos x. We're going to stop there, and we're going to use what we've been using for the last today for the forms, the double angle, is we know, just by looking at that sheet there, it is 2 sine x cosine x. We made it.
wait, so sine 2x is...
It's right there on the top. Look at your sheet.
That's so awesome.
2x is 2 sine x cos x. Right there at the box there, dear. Sine 2a. Says 2 sine a cos a. Yeah, so there was really no math there either. Just replacing it, right? Yeah. Okay? It's all right. We're going to power through. Sorry. I know you guys don't want me to, but we're going to. All right. So example 2. Use the identity of sine 2a equals 2 sine a cos a. It's one we just did. With a replaced with 3x to determine a double angle for sine 6x. And so what they're saying here is we want to do sine 6x, but we want to write that as a double angle. So how do we like things to be written when we want to do double angle? We want there to be 2 times something. Exactly. 2 times 3x. So we want to write like this so we can use a double angle formula. So we just pull the 2 out of it. Because now it meets our requirements, right? What's our a? 3x. So now it's sine, I put the 2 in there. 2 sine 3x cosine 3x. Done. That's a double angle identity for sine 6x. So, Hannah, look at the sine 2a at the top. That's the identity. Yep, that's the identity, dear. Yeah. I know. Okay? So, we use the identity. That's how we got there. No, it's not. You're trying. I appreciate it. Okay, so cos 10a. Cos 10a. How can we write that one? Same directions. Right. Cos 2 times 5a. Cos 2 times 5a. So that means it's a cos one now, so we're using the cos one. So we're going to use, it's going to be cos squared 5a minus sine squared 5a. Because that's the cos one, right? Because we're in the middle now. We're doing the cos double angle. It doesn't matter. Yeah, it doesn't matter which one. When asked which one of the 3, it actually doesn't matter. I just use the top one. It's the one we're familiar with, and that's the one we proved. Okay, yeah?
I was going to ask that question.
That's good. There you go, there you go. Now tan x. Darn it, they're making use fractions. So if I want to use a 2, I have to make the x have a what on it? A half. 2 times a half's a 1, right? 2 times a half's a 1. So your a is 1/2 x. And now we're using the tangent 1. Which number, dear? Good. So that's a great question. Okay, so Tori, we want to use double angles, so we want to write tan 2 times something. But I can't change what's there in terms of value. So 2 times what gives me 1? Well, 2 times a half does. And so now that's because this right here equals this. It's kind of like we're unsimplifying to use double angle. So the numbers come from that's what happened to all of them. See, we put a 2 here. 2 times what is 10? 5. Right here, 6. 2 times what is 6? 3. So that's what we're doing. We're saying a 2's here. What do I need to multiply by 2 to get what's already there? Okay, that's a really good question. Okay, so tan 2 1/2 x. So now I'm using the tan formula on the far right. So it's 2 tan 1/2 x all over 1 minus tan squared 1/2 x. And that is it. One more section. Hang in there. Okay, questions? Sorry, what's your... You can. It's fine. Finish, you crazy kids. Okay, so we got 2 sine 4x cos x. So since we're going backwards. So 2 sine 4x cos 4x, you can see that that is the sine, right? Because it's 2 sine cos. So then we can write this one as sine 8x. So sine 8x is that. Yep. I mean, I may have skipped a step if you want. You can write it like this. Sine 2 of 4x first, and then sine 2 of 4x is 8x. Probably should have done that, sorry. Okay, the next one's clearly a cosine, because you have the cos squared, sine squared. So this one is, and they're half a's, okay? So that's going to be cos 2 times 1 half a. So what's 2 times 1 half a? Just a, yep, just 1. Cos a, done. Bless you. That's the formula. Yeah. The cos double angles are squared. Okay, last one. Now this one's really tricky, okay, because there's no, it's sine cos, so what are you thinking? You're thinking sine, which is correct, but there's not a 2 there. So what we have to do is kind of create a 2, which is going to make you nuts, but you're going to go 1 half times 2 sine 5 halves x cosine 5 halves x. So I talk about this kind of unsimplifying idea. I added a half to put a 2. So now I can convert this stuff in the bracket to the double angle. Okay, so let me say that again. I wrote a half to get a 2 so that I can do stuff to make this a double angle. So now just the half just hangs out. The half is part of your answer. That's cool. Now just worry about this. What would that be now? Sine of 2 times 5 over 2x. Right. Yep. So it'd be sine 2 times 5 halves x. The 2's cancel, so you essentially get, I'm going to come up here around a room, you get 1 half sine 5x. Okay, are we close?
Oh yeah, I got it.
All right, good. All right, that's it.